Hi everyone, hope you are doing fine. So from today I am going to solve the like a past contest of the lead code and will be going to share my thought process. And alongside this I am also started learning Java and Spring Boot and will share about that thing also on YouTube and whenever after some time also thinking of starting doing this thing on a live stream. I am going to go live on the YouTube and will solve this contest and learning stuff like low level high level design or other things. So yeah, so let's start with the bi-weekly contest 185. So let's start the virtual contest. So let's see how many question I will be able to solve. So yeah, so the first question is create grid with exactly one path. So you are given two integer m and n representing the number of rows and a column of a grid. Construct any m cross n grid consisting only of characters, yeah, hash and a dot, where dot represent free cell and hash represent the obstacle cell. A valid path is a sequence of free cell that start from 0 0 and that a last cell m minus 1 and n minus 1. So yeah, and right move like we can only move right and the down. Return any grid such that there is exactly one valid path from the top left cell to the bottom right. So so yeah, the problem is quite simple. So in this let's take example and try to dry run here. So yeah, let's see this 3 cross 3 example. So we are taking a 3 cross 3 matrix like n is 3 and m is 3. So we have to make a matrix of n cross m. So we have to make matrix of n cross m so that there will be only one part from n from this 0 from 0 0 to n minus 1 and m minus 1 like this. You can say like there will be only one path, and the dot mean like it is a free path we can move, and hash mean that there is an obstacle on that path, so we cannot like on that cell, like if there is a hash we cannot move from like here to here. And also and only two types of moves are valid in this. Like first one is right, and another one is the down. So you can see like here it's mentioned like we can only move right and the down. So yeah, so what is the path? Like we can choose any path, like simply we can simply choose this path. We can move firstly move right and then move to a bottom, and then after that we can make add obstacle to every place. So yeah, so this is this thing. So if we add obstacle everywhere and only choose this path, then we will get answer. So in this what we have to do, so we have to start firstly we have to start from 0 0 and move to like x will remain 0 and y axis will move. We have to sorry yeah like this is x and this is y. So x will remain x will remain same, and we only increase the value of y from 0 to let's say like if we have n cross m, so we have to move up to m 0 to m minus 1, and then we have to move from 0 to m minus 1 to n minus 1 comma m minus 1, because now m will remain same, like this m value m minus 1, it will remain same. So yeah, this is quite simple question problem. So let's write the code for this. Mm, so instead of we have to simply return it in a uh, string form, string format. You can say like we have to write this for this we get answer like something dot 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 hash 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 and hash. So first group will be like something like this, second will be like this, third will be like this. So we have to return an array of a string like this. So yeah, so let's see how we will go. So firstly we can simply declare a vector of vector, sorry, vector of string, and name it as answer and simply return this answer. So now we have to move from like we have to move from I equal to 0 to I less than equal to n and I plus plus. Now for like we are going like this. So for I equal to 0 we have to mark everything as a dot. So like if I equal to 0, then we have some thing like then we have to move from int I like j equal to 0, j less than m and j plus plus. So like we can replace this as nmm because we are taking n as the number of row and m as a number of column. So we simply do answer dot push back. Sorry. Yeah. T, we can simply declare a string t here, and simply at last we are going to push it into our answer. Answer dot uh, push back t. Yeah. So we are going to t dot push back. In this case, we have to only add the simply a dot. Because for I equal to 0 or it will always going to be a all dot, and for for other case we are going to like so this will loop will start else condition will start here. So in another cases we have to do from j equal to 0, j equal to m and j plus plus, and if like j equal to m minus 1, if j equal to m minus 1, then we have to push back t dot push back dot, else it will going to be hash. So yeah, I think it should work. So let's see, is it working or not? I think it is not working. Yeah, it is working right. Yeah. So yeah, so you can see that. Let's try to submit this out, and then I will also explain you code for this. So yeah, this is working. So let's see what we are doing. So let me paste this code here. Why it is not expanding like this? So yeah, let me explain this thing. So like we are doing same thing in here all here. You can see like firstly we are iterating from I equal to 0 to 1 like same like firstly we are traversing this, then this and this. And in first case if I equal to 0 we are marking all the as dot. So you can see like if I equal to 0 I am marking everything with a dot, and after that I will push into our answer. And for second and all the thing I am marking all as hash except the last one. So you can see if j value is m minus 1, then I am adding dot, else I am adding hash. So yeah, so this is quite simple. I think I hope you understand this. So let's move to the next problem. Minimum lights to illuminate a road. So you are given an integer array lights of length and representing position 0 to n minus 1 on a road, and for each position I, light of I value is light of I equal to V, where V is greater than 0. There is a working bulb at position I that eliminates every position at a position from index 0 to yeah 0 to I minus V. Okay, okay, like a max of 0 comma I minus V and a mean of n minus 1 comma I plus V inclusive. Yeah, so if light off is 0, there is no working bulb at that position. A position is visible if it is illuminated by at least one working bulb. So you may install additional bulb at any position. Each additional bulb installed at J uh, J illuminates position from 0 to max of 0 comma J minus 1 comma mean of n comma 1 comma J plus 1. So yeah, return the minimum number of additional bulbs required to make every position uh, on the road visible. So yeah, so let's understand the problems clearly firstly. So in this problem, what we have given, we have something like we have given a yeah array of lights. We have given something like array of lights, and if the value of is it is a one, or like it value can be anything like 0, 1, 2, or we can say, let's take example like this 0, 0, 2, comma 4. So if there is a bulb like at 0, 1, 2, 3, let me write indexing for this. Like if bulb is at position 4 and its value is 2, so it can illuminates like it can give light to like two previous steps and the next two steps. So like it can light up this like this bulb like three index bulb and two index bulb also, and also four index bulb of sorry, five index bulb also. And if so you can see it also there is a bulb at 0 position which can illuminates up to one step, so it can illuminates up to this step and one forward like at minus 1. So we can simply ignore this thing like, and we will try to find the like where we cannot illuminate, and after that if we can place a bulb at any position by our choice, and when we place that bulb it will illuminate the from like j minus 1 and j plus 1. By this we mean that like if we, let's take some another example in which all are 0. So in this the all are 0, so we have to put the minimum number of bulbs to eliminate this thing. So like if we place bulb at this position, 0 position, 0, 1, 2, 3, like a 0 position, it will eliminate this minus 1 and this 1. So there is no need to add some add bulb at this position. And similarly we can, if we add this, it will eliminate at this point 1, 2 and 3. So we have to simply return the minimum number of extra bulb, or extra bulb or light we can say have to add. So first thing is that we need to check we need to firstly find the index of all the positions where bulbs are not like where another bulb cannot eliminate that point. So firstly we have to find that thing, and after that if we have find that thing, we have to do like let's take something example like example of 5. So we have to like return the like if we have something like this, and we have to return the how many number of bulbs we require to eliminate all these things. So like if we place bulb at this position 0 and this position 2 and this position 4, so like this 0 position will eliminate the one thing, and 2 will also eliminate 1 and 3, and 4 will eliminate itself and the 3. So yeah, so in this case we required 3 bulbs, but can we do something better than this? So let's see, we have something like a 5. So instead of placing at first, so we can place at like second. Here we place bulb at here, so it will eliminate one previous and the one next. So it is also already eliminate, so we will try to eliminate this, but we will not do this. We will try to eliminate this, because if there is something like next here present, so we can do previous and the next, so we will do something like this. So yeah, so I think this is the main crux of this problem. Like there are two things. So firstly, we have to find like what are the position where we cannot eliminate, and then we have to do something like number minimum number of moves like we can say minimum number of bulb required to eliminate all these things. So like in case of 6, we have to do two bulbs, add two bulbs, first at one position and another at fourth position. So this will yeah, done. So now the problem, so we get this how we can do this. So I will, whenever I write the code for this, it will be clear to you. But now let's see how we are going to find like which bulb is not eliminated. So like if we are going to do with something like, let's see constraint of this problem. So yeah, the constraints are up to 10 raised to power 5, and the light of I value is also up to 10 raised to power 5, we can say. So we have, so we cannot do something like let's say we have something like a value 4, we have something like array like this 0. So so we cannot do something like this, like we can check for 4 left on 4 like left 4 and the right 4, then for this left 5 and the right 5. So like by if we do by this way, it will be like n square approach, I think. Yeah, or a little bit more than this. So let's see how we optimizely do it. So instead of doing this, we are doing something like a prefix sum technique, in which, like, let me define firstly indexing for this 0 1 2 3 4 5 6 7 8 9, and let me add 10 and 11. Yeah, and here 12 is 1. So we are going to do maintain prefix sum. So let's say for this 4, we can mark something like its previous 4, like from 0 we can go up to 4. So we can mark 1 as 4, like uh 1 at its starting position. Like what is the starting position? It will going to be a max of 0 comma, like index minus that value, like 0 minus 4. So in this we are going to add like a 1 at this position, and up to where we this bulb can eliminate. So it can eliminate up to 4 value. So we do something like where up we can last value at 4. So we are going to add minus 1 at the 5 index. So after that, like by this we mean that there is one from this position to everywhere. Like if we move for like a forward, there will be all one. Like if there is one, we also mean it means there is also one, there is one, there is one, there is one. But when we do 1 plus 1, 1 plus minus 1, it will going to be 0. So by this it means that it all the another value will be going to be a 0. So it means that it can eliminate up to this point only. So yeah, so we are going to build this for every index. So let's say for 5, it will going to be like starting will be from uh 5, like 1 minus 5 is going to be minus 4. So it will be start from here. So this value become 2. So then its ending, like its ending will be going to be 3 4 5. Its ending will be at index 7. So we will add minus 1 at 7 position. So yeah, so for 6 again, it will going to be 3. We are going to add 1, and at index 9 we are going to add minus 1. So similarly for 4, it's going to be, it become 4, and index 4, it is going to be like index 8, it is going to be minus 1. So for 0, we do nothing. For 1, we place 1 at this place, and minus 1 at 7. So it is going to become -2. Then similarly we will try to do for 2. For 2 it is going to become 2 here, and then after this here it is also going to become -2. Then similarly here will be 0 0 0, this all going to be a 0, and after this 1 it is going to here 1, and yeah, and for -1 we can add something like one more index like 13 at -1. So yeah, so after doing this it will prefix some like 4. Here we are going to 4 4 4, and it's going to become 6, and then it become 5. Here it become 3, here it become 2, here it becomes 0, and yeah, here 0, here 1 1, and here it becomes 0. So you can see where the value is greater than 0, it means that we can visit, like it is possible to eliminate that point, that bulb, or we can say that, yeah. So in this case only these are the two places where we cannot do we do not eliminate. So yeah, sorry, only one place I think. No. Oh, sorry, these are the two places like 9 and 10. So yeah, in this case we need, if we place bulb at this position 9 or 10, it going to give like eliminate all the bulbs. So in that case our answer will going to be 1. So let's see, let's so write the code for this and see how it is going to work. So yeah, so let's name it as a v and int n equal to v dot size. So firstly we have to maintain some prefix array. So let's name it as a prefix only, prefix prefix of n plus 1, and initially all value will be the 0, and then we move from 1 to yeah, or we can say comma, we are going to iterate our array, and then, oh sorry, we also need index, so instead of doing this loop we can use simply this loop. So yeah, so in pre-index, like previous index where from where it can contribute to answer, like what will be going to that index. So pre-index will be the I plus like sorry, I minus v of I, and next index is going to be uh I plus vi plus 1, because we are adding, like if we are ending at this position we are adding -1 at next position, so that we will like eliminate the previous point. So yeah, these are the indexes. So now after doing this let's see, yeah, I think these are the thing. So after doing this we can simply make prefix of pre pre-index plus equal to 1, and a prefix of pre-index, sorry, next index is going to be -1. So after that we are going to simply add this thing. Let's say in, like we can simply name it as a sum, or sum is initially 0 and sum plus equal to prefix of I. So as this value can prefix in sorry, if we miss this case, like if pre-index is less than 0, we can make pre-index as 0, and if next index is greater than n, we can simply make it as n, because if we move backward or forward from like a 0 and our range, then it will not contribute to our answer. So yeah, so then we are doing sum plus equal to prefix index. So then we are going to iterate the array and simply like maintain a count variable in count equal, like we are going to count the number of values where value is 0. And if like if prefix of I is going to be a 0, then we do count plus plus. Else we check if our count is greater than 0, then we like you can see for 3 we required something like this, like if there are 3 empty bulb, this can be done with a one, like 3, if there are 3 empty bulb, if we add light at one place, it can eliminate these 3 bulb. So yeah, if there are 4 we need one more, if there are 5 we need 2, if there are 6 we need 2, if there are 7 we need 3. So you can see like we can simply do like if n divide by 3 plus n modulo 3. So like by doing this we get like we can divide, like if the number is like in case of 7, 7 divided by 3 will give 2 in integer, and n modulo 3, like if n modulo or we can say that if n modulo 3 is not equal to 0, we can simply add one more. So let's write this like we can say answer plus equal to count divide by 3 plus, like if count modulo 3 equal to 0, we are going to add 0, as we are going to add 1. So at last we are simply returning answer. And let's say we define here, let's define here answer variable. So let's see is it working or not. So for first case it is giving us a 0. So yeah, so we miss this case, like if because there may be chance count value can be greater than 0 after last case, like last, if last value is 0 this will not work, so we have to write explicitly condition for this case. So we are doing this at last. So yeah, count modulo 3 equal to, if count modulo 3 equal to 0, then add 0, else add 1. So I think this will work. So let's me debug this thing. Why it is not working? So what is the value of count? So the count is 3. So let me print this prefix array. So it is IT. So how this prefix value is 1 initially? So we are what we are doing, like if the prefix index, if the value is 0, then it becomes 0 minus 0, it will remain 0. Yeah, and in case of this, so yeah, so we can simply skip the case, like if v of I value equal to 0, then we can do continue, because we are adding like, let me explain this thing. So first let me check if it is working or not. Again it is not working. But I am not setting this prefix I value to be a sum. In first case we are getting 2, but in second case we are getting 5. How is it even possible? So I missed this thing. I think now it should work properly. Let's try to submit this out. So yeah, so it is working fine. So let me remove this cout statement and now try to submit this out. So yeah, so you can see that I am doing the same thing that I explained earlier. So what I am doing, so simply like if the value is 0, I am skipping because there will be no contribution from a 0 light, because it cannot eliminate like itself or next or previous value. So this is the case, I am skipping out, and else it will like it will start from pre-index to the next index. It will eliminate from this value to pre-index to the next index, and after that I am simply making like if the prefix value is calculating some prefix sum, and if the prefix value is going to be 0, it means that we have to eliminate that thing, and I am simply increasing the count. So like why are we not simply do like count, like simply increase all the count, and at the end we are doing something like this? Why we are doing at every set? So let me explain this thing. So like if we have something like this, so if initially we have something like this, so you can see that this one can eliminate this thing, this one can eliminate this thing. So now for this 4 we need to like if we don't if we count all the 0, let's say 4 plus 2 5 6 plus 1 7, so 7 divided by 3 is going to be 2 plus 1, like we need 3 bulb to eliminate all this thing, but it is not possible because like these are not connected, like no, you can see like to eliminate this thing we need two bulb, one to eliminate these three and another to do this, and for again for same we for these two we need one bulb, and for again for this we need one. So in this case the answer will is the minimum answer possible is 4, but we are getting 3 if we are going to maintain like a global counter. So I hope you understand this problem. So let's move to the next problem. So I think it's a graph problem. So let's see. I will be able to solve this or not. So you are given an integer and representing the number of tasks in a project. You are given an integer and representing the number of tasks in a project. Number from 0 to n minus 1. And these tasks are connected as a tree rooted at task equal to 0. Yeah, it's like a tree rooted at index 0, like node 0. This is represented by a 2D integer edges array where is a edge from UI to VI indicates that task UI is a parent of VI. And you are also given an array base time of the length n, where base time represents the time to complete the task I. The finish time of each task is calculated as follow. Time to complete this task, yeah. And the finish time of each task is calculated as follow. Leaf task. The finish time is the base time. So for the leaf node, the finish time is the base time, which is we have given, and for the non-leaf task, let earliest be the minimum finish time among its children, and latest be the maximum finish time among its children. For non-leaf task, let earliest be the minimum finish time among its earliest be the minimum time among children, and the latest be the maximum finish time among the children. So let on duration will be the latest minus earliest plus base time. The finish time is of task I is latest plus on duration. So yeah, they have given some complex thing like, so let's copy this and try to decode what are they trying to say in this. And yeah, let's copy this image also. Why there is no option to copy this image? So yeah, so as the tree are not big, so let me take some big example. So what they are saying that, so we have something like a given like a tree. We have something let's say we have something like a tree given which is rooted at index like we can say at node 0, and it has something like some child node we can say. So as it is a tree, so it is always going to be disconnected. So for the leaf node, the time to complete this task is going to be a base time. So as we have given a base time array, so time taken to complete this task is going to be a base time. So for same this also, and for this. So but for this, how we calculate for this? So to calculate the answer for this, so we have to consider these things. So leaf types, for the leaf task the finish time is going to base time, and for the non-leaf the earliest be the minimum finish time among children. Like, so let's say we have this three node has hundreds of children. So we have to check which what is the minimum for them. Let's say it is going to take 1 minute, or we can say two, it's three, and so on to up to 100. So the earliest is the one, and the maximum is the 100. So then what is on duration? On duration will be the latest. Like latest in this is 100 minus 1 plus base. Let's assume its base is 2. Like its value, its base time is 2. So it's going to be 100 minus 1 plus 2. Let it's going to be 101. So it become its on duration. So the finish time of task is latest plus on duration. What is latest? Latest is 100 plus it, what is its on duration? On duration is 101. So it's going to be a 201 for this thing. So again we can solve this recursively for this also. So firstly we are going to solve for this left child, then for right, and so let's say we calculate for this, we are no, let's say it's for 2, it's for 3. So again we will calculate using this same formula for this. Let's assume we are getting here as a 5. So again, so what is the minimum? So then again we will going to calculate for this same, what is minimum and maximum of this child, and then again calculate the answer for this. So yeah, so we can calculate the answer for the one, and else we throw this at recursion. So recursion will solve the answer, and we will simply get the answer. So let's see how we are going to do this. So like whenever we need like our base case, what base case going to be like, if there is a no left and right node. So like this is a condition to check if the node is a leaf or not. If there is no left and a right node, it means that the node is a leaf node, and we are going to simply return the base time for that. And if it's not if this child if it has a left and a right children, for that we have already calculated the answer, so we can use that answer. So let's write the code for this. So yeah, so answer is expecting LL long as answer. So let's define using LL equal to long. So firstly we have to let's say we are going to be, we have something like edges. So in this we are not given a tree, but we have given edges. So from these edges we can make something like a adjacency list for so that easy for us. So let's create firstly the adjacency list for from here. Uh, Adjacency list of size, and so as the value starting from 0, so we are going to take off size, and after that we are going to iterate edges and do something like uh adj of it of 0 dot push back it of 1, and similarly we can simply reverse this thing, t of it is going to it of 0. So yeah, we get urgency list. So firstly we need urgency list, and after that the node and parent. What is a parent? So we cannot do again for parent. So we are going to iterate the adjacency like all the child of that node. And yeah, so after doing this, so firstly we have to do two three cases. Like firstly, like if what happened, like if the this node is a child node, let's say we are at this node. If you are at this node, there will be the no children node of that. So we have to maintain that. We have also tracked like if there is a no children, then we have to do something. So in that case, what we have to do, we can simply check. We can simply maintain a count, and so we need the earliest and the latest. So start equal to 0, and we can simply maintain it as start and end. Initially start and end going to be a 0. Yeah. So if there is a, if it is not equal to a node like a parent node, then we can simply again call this function like the same thing, and while returning we are checking. So we also need a dp of like what is the size of and is, or we can simply maintain dp vector here only. Yeah. So start is going to be a min of start comma, so we can make it as int max and end as int min. So as it is a long, so we can make it as a long max and long min. So it will be going to be a min of start comma dp of it. Yeah. And end is going to be a max of and comma dp of it. So we can simply ignore this count, like we can check if the start value is already equal to long max, then it means that it is not possible. In that case, we are going to simply add that base thing. So yeah, so I think this is the thing we have to do, and we can check if start equal to long max, long max. It means that it is a child node. In case of child node, the dp of node value is going to become the base time of that node. So we also need here a vector of base time also. So yeah, else in another case what we have to do, so let's see again the formula. So yeah, earliest will be the minimum, and we have done this. So let's say int ll on what is going to on duration is going to be a so on duration is going to be a and minus start plus base time of node, and ll like a deep, we can simply define dp of node is going to become the and plus on duration. So yeah. So yeah, so let's see what are they asking us to return. So they are asking us to return the root value. So we can simply, after doing this, we can simply return this thing like a return dp of 0. So we need something like a vector dp of n comma. We can define it as a minus one, or we can simply ignore this thing also. So it is going to be n plus 1, let's say. So yeah, we can simply call this a function. We have to pass adjacency list, and then node and parent. Node is going to be 0, and then going to parent is going for 0, it is minus 1, and then we need dp and a base time. Yeah, I think it should work. So let's see. So there are syntax mistakes. Let's see. So I also have to pass base time here also. So yeah, as we are not returning something and anything, so we can simply return, we can make it as a void also. So let's see, is it working or not? I am getting 10, 5, 6. So let's see. Let's print this TP array completely and see what are these values. 10 minus 1 minus 1. I think adjacency list is properly declared. We are iterating all the edges and do like IT of 0, then push 1, and IT of 1 push 0. Yeah. So we are doing some continue. We have to do continue in case of if the IT is equal to parent, and in else case we have to do like all these thing we are doing. So it's giving us segmentation error or runtime, I think. So vector int base time. I think base time array should be of size 2. Yeah. And so initially the node is going to be a 0 and all the node. So yeah, I think it should not give let's again run this thing. Let's print the value of node which we are going to be assessing this base time. So yeah, so no console is printing. address deadly signal. So let me this log this thing for checking why this error is coming back. Why is this giving us error? Like we are not doing anything with the base time. Let me pause. TP same as again we are getting like base time is going to be same as the n size, no? Yeah, you can see. Then why we are getting this error? So yeah, I am get this. So I get this, I think. But again, this is giving same error. We are passing adjacency list int and parent and a base time. Yeah, dp comma let's pass dp here also. Then why are we getting this error? Vector int and base type is as a time, simply time. Parent is going to be a node. So yeah, so I think it was like completely mashed up. So yeah, so let's now try to run this thing. Getting 7 as an answer, but it is 17. So yeah, let's see. And it's going to be a base time here also. For node 3, it is time is going to be 3. Yeah, but I am getting it as a 4. How is it even possible? Node equal to 2. Let's write the start value also. Start. So it is going to be LL because we are assigning the larger value than its range. So it is going to become a minus. And then we are doing something like a DP. Also, we can make this as a LL. So I think I made all mistakes. I have made more mistakes in this code than its actual like uh, yeah. So I think it is now working. So yeah, let's comment these things and try to run this code. So let's try to submit this thing. I think it should work. Memory limit exceeded. So what are we doing extra thing in this problem? So yeah, so I think like as we are maintaining this thing in our like a DP. So instead of maintaining this DP, we can simply return this thing and simply calculate this from here. Like LL temporary answer is going to be instead of DP we are going to use temp answer, and similarly we are going to use temp answer, and yeah, so instead of this we are going to return this, and similarly we are going to return this. So we can simply remove this else condition also. So we don't need this TP. Also this TP here also, and this thing also. So let's now try this. So now we have to simply return this thing. Yeah, and we are return this thing also. S- 17, 12, 10, sorry 18, and yeah, so let's try to submit this thing again. So again it is going to, it's giving us a time limit. Oh yeah, so one thing is like we are passing by a value, not a reference. So every time whenever function is called, like a recursion is doing, so it is like a part, so new copy is created. So yeah, that's why I think DP solution will also work. So yeah, so let's try this, and then again we will try to submit that our DP solution also. So yeah, you can see this is working. So let's again try to submit this our DP solution. Yeah, I think this is our DP solution. So yeah, let's copy this and firstly run this. Is it working or not? So yeah, you can see like it will also going to work now. Let's submit this thing. So again we have to pass by reference. So let's submit now. So yeah, you can see this, it is also working. So yeah, I think this question is a little bit tougher than first two problems. So let me explain this thing. So what I have done in this. So yeah, so instead of copy pasting it, I am going to take this screenshot and going to paste here. So yeah, so let's see what I do in this problem. So firstly in this problem, so we have something like a tree. So yeah, I think now you have understood, like you understood the problem clearly. So let's see. So firstly we have something like a tree. So yeah, I think this tree is enough. So for the for the leaf node, the base time is their time to complete that task. For this like for all the leaf node, the for this the time to complete is the base time. So to calculate the answer for this, so we have to do something like this. We have to do we have to take the max. We need the max and the min of all the child. So let's say if there are multiple choice, by anyhow we calculate like, so assume we get this thing, mean and a max thing. If we get mean and a max thing, so we are making mean as a start, like start, and a max as a end thing. So if we get this, so to calculate the time for this, the formula we provided in this problem is this. Like to firstly we have to do calculate the on duration, which is going to minus and minus start plus the time, the base time of that this node, and at the last time the base time for this is going to be actual time to complete this task is going to be and plus the on duration. So yeah, so we are doing like if we do this we calculate for this. So after you can see like if we do for this, again we have to do similar thing for this. Again we have to do similar thing for every node. So you can see whenever we break a problem into a similar type of sub problem, like we have given a very large tree, we break like we calculate for a single node, then we move try to move the upward, and then again we see how we calculate for this node. So yeah, so in this we have to firstly calculate all the answer for the left side node, then for the right side node, and then we calculate for the parent. So yeah, you can see what I am going. Firstly, I am from this we have given edges array, and from that I am creating the adjacency list. And after creating adjacency list, I am pushing like a both node. Like there may possibility like in this problem we have given something like as the tree is rooted at 0, it's from a like a 0 to 1. But in edges it is mentioned like there is edge from 1 to 0. So to like, so in this case if we start from 0, we will not never be able to come to 1, because there is a edge from there is a reverse edge like from 1 to 0. So to handle this case, I am doing this thing, like reverse thing also. And after that I am simply traversing, like if I am node, like if I am at nodes this node, I am then moving to its child, firstly child node, and then again I am moving to its child node, then again I am it's moving to child node. And after that if there is like from here, this loop will not run, like this loop will not run, because there is no child for this node. As there is no child for this node, this start value become like remain the long max value. So after like if the start value is long max value, it means that it is a root node, and for the root node the time to complete is the base time. So I am assigning that value to this thing. So yeah, so like now as I have maintained the DP array, so for let's say it's the DP of 6, like it's a node value 6. So for at node 6 I am writing storing this answer, and then for similarly for after that I am going back, like this is recursion will be our going back, and then again I am moving to another node. Like if I am starting at this node, I traverse to this, now I move to this node. Again from this node, this is a like a leaf node. Again for this, the start value is going to be long max, and then yeah, then we are assigning to we do this. And after that now now there is no child for this. As there is no child for this loop will over. And like now you can see like after after this call we are also maintaining these two things, the start, and the end. So by maintaining the start and end, we are maintaining the like what is the maximum value of its all the child node and the minimum value. So by doing this we will getting the answer. So like we it's a simple formula. I already explained you. So at last we are returning dp of 0. So yeah, so we can see instead like we are calculate simply maintaining dp, we can also do it in a better way, like without this dp state. Without dp we can simply instead of simply calculating here, we can simply return from here and simply maintain, like check what is the mean and max and simply return. So yeah, the code is here for that case also. Let me again show you a code. So yeah, so this is a code. You can take screenshot of this and try to understand what I am doing in this. So yeah, so let's now move to the fourth problem. So I think it is a math problem, so let's solve this also. Count a good integer in a range. So you are given three integer L, R and a K. A number is considered good if the absolute difference between every pair of adjacent digit is at most K. A number is considered good if the absolute difference between every pair of adjacent digit is at most K. Return the number of good integer in range L and R. The absolute difference between x and y is defined as absolute of x and y. So I think L and R is going to be a very large. Yeah. So the problem is quite simple if the constraint are going are very less. So the problem is saying a number is considered good if the absolute difference between every pair of the adjacent digit. Like if the number is like we have number like 201. So for 201, the absolute difference between every pair like 20, like every pair of adjacent digit, like in this 2 comma 0 are adjacent, 0 comma 1 are adjacent. If their difference is at most k, like maximum it can be a k. It means that if the absolute difference between this is going to be less than equal to k, it means that it is a good. Like in this case the k is 2, you can see that it is a less than 2. So 201 is a good. So let's say now we can check for 202. In this also like a number is difference going to be a max of 2 for 203, but 0 and 3 difference is 3, so it is not good number, not good number. So yeah, again for 204 the difference between 0 and 4 is quite high, so it is not possible. So yeah, so the simple way is to do this, like you can see the L and R are quite high, like 10 raised to power 5. So it's up to, if it can be up to 10 raised to power 6, we can simply run a loop. Like let's say, let's firstly write that code. So in that case we can simply yeah, we can simply do from L to R, but yeah, this is going to be give a TLE, so we can make like string as equal to to string. We are converting that number to a string, and then we are going to traverse that string int I equal to 0, I less than n I plus plus, like sorry, I equal to s dot size, and instead of I we can take a j equal to 0, j less than s dot size, and j plus plus. So yeah, so if the so we can do simply -1, so we can simply compare the next element. So in next is going to be a, so we can simply do s of j minus this, and in pre is going to be a s of this is going to be j plus 1, s of j minus g 0. Yeah, so if the absolute of next comma pre is going to be less than equal to k, then we will continue like so we can yeah, so we can simply check if reverse, then we can make this condition as false. So yeah, initially this condition is going to be a true, and if the condition is true, it means that we get our answer. So we do answer plus plus and simply return answer. So yeah, let's try this. So for 1 we are getting 3, and for 2 we are getting 2. So let's try to submit this. It is going to give a TLE for sure. Yeah, you can see it is giving TLE. So like we have to do some we have to think about some optimization, how we can optimize this thing. So as k is always k is less than equal to 9. So instead of doing simply doing this, let's say I think it's simply a bit mask DP problem, I think. Yeah. So let's try to solve this thing also. So so instead of simply checking for every number, so instead what we can do, we can simply try to generate all the possible number. So I think we can simply do thing like that. So if we have to something like we have to calculate like number for 2 like to calculate good number between this thing, like from 1 to 2 to 2. So firstly we can simply generate 1 2 3 4, like these are going to be number, and in this the k is going to be 3. So like if the k is 3, then we can simply make first number, if we choose first number as 1, and how many like digit are there, 3 4 5 6. So as there are three like six values, like 6 digit, so we can place let's say we can place 1 at first. Now at second we can place from any number from 0 to 9. Yeah, let's say we place 0. From here also let's say we can place 0 0 0 0. So by doing this we can try this number, like if first if we make this number, then from here we can, instead of 0 we try 1, then then we try 2, then we try 3, like we try 3, when we try 4, like as the difference between these two number become greater than k, so we cannot do this thing. So yeah, so you can see like 4 4 4, like if these three number are fixed, then for this three value we have to place different number, like, and the k is going to be fixed for a whole, like if we are calculating answer for some problem like yeah, test case, then k is going to be same. Let's say k is 3. So if there is a 4 present at this index, then number of ways to make this thing is going to be same. If this thing is like 114, so you can see like if there is a 1 present at this position, like a 0 1 1 at 1 and 4 at 2, for this the combination is going to be same, because in these three places we can simply make same combination, like if we place 4 like 5 here, we can't place like something like a 9 here, or we can something like 8 here, because if we place 8 here, the difference is going to be a greater than k. Yeah, so I think by doing this thing, so firstly we are going to try all the possible combination, and then by using DP we are going to optimize this thing. So I think that it's going to be tough for me also to write code for this. So let's say, so yeah, so let's write the code for this thing. And after writing the code, I will uh explain it in a more clear way. So yeah, this is a, I think like there are a lot of problems like this on CSC problems at also and lead code also. So yeah, let's solve this problem. So we have something like int l comma r comma k, l r k, and s dot good integer l r and a k. Yeah, int answer l answer c. So let's try the example. 10 to 15 we have uh three answer, 10, 15, and a k equals 1. So yeah, so now let's write the code for this. So we have something like it is going to be return n, and we have something like a start, or we can say we have something like a current value and string like we can say like and value, like uh yeah, string and we need something like index, and what else we require? Yeah, let's see. So if index equal to n dot size, we can simply return 1. So it means that we find one answer and it's maintain, let's say k. So yeah, so also we need something like a tight thing in this. So yeah, so we can say I0 I less than n I plus plus, instead of n it is going to be a 9. So if tight is true, like if tight is true, so it means that the current we have not previously chosen the max value. So let me firstly explain you what the concept of tight, what I am, why I'm maintaining tight in this. So yeah, so like if I have something like a number like 6, 2, 3, I like this, and now I have to maintain all the combinations. So like for 6, if I choose 1 here, then I can add 9 here, because it is always if the previous number is less than, like you can see that its previous number is less than like this current value, this value. So I can add 999 or 88, whichever number, it is always going to be lesser than that. But if I choose 6, I cannot add greater than these two, like I cannot also add 3, 4 or something like that. So to maintain this thing, I am maintaining the tight. So like by tight it mean that if the tight is false, it mean that I have already chosen some smaller number. Like if it's a 6, I have already chosen some 5 number, and now I can place whatever I want, 9, 1, like from 0 to 9, anything. And if the tight is true, like if the tight is true, like it mean that we have something like same value, like if it is 6, then here we have 6. Now here I cannot add the greater than this 2. So yeah, so let's see. So if the tight is true, it means that I cannot add the greater value than the current value. So what is the current value? In current value is going to be a s of, so instead of doing this we can simply maintain a pre value only. No need for maintaining all the values. It is going to be s of n minus 0. So yeah, if the type is true, if I is greater than current, we can simply break this thing because we cannot do further thing. So yeah, else we can simply continue. Else what we like yeah. So if the type is true, it means that pre, like we are choosing pre I as a pre, and is going to be, and this is going to be a same, and index is going to be a plus 1, and k is going to be a same, and tight is going to be a tight. If tight is like, if a tight like if I value is less than tight, it mean that tight is going to be now false. And if I is like if I is equal to tight, it mean that it is going to be a true. If I is greater than current, or we have to also check the absolute difference between the previous and, like, if pre, if absolute of pre minus current is going to be greater than or equal to sorry, greater than k, then also we have to break this thing as we do this thing. So in this case, if the trait is true, then we have to check nothing except one thing, like this absolute different thing. As we can simply add I and remain and index plus 1 and k remain k, and that trait will always going to be a trait because that already trait is false. So yeah, we can make it as a false. Answer plus equal to answer plus equal to, and simply return the answer. And also we can check if the absolute of pre minus current is greater than k, then we have to break this thing. So yeah, I think it should work. So let me try to run this for function of what is going to be a pre value. So we have to check this condition only, like uh if index is greater than 0, because if id index is 0, we it's our first element, so we can do like choose anything, like yeah, let me explain this thing. Like if we have some, we are take example like 6 to 3. Now if we are going to choose 6 here, we can choose this 6 because it's the first element. So we have to skip this case, like we don't need to check for this, like if the index is 1, like we have to do this thing if index is greater than equal to 1. Yeah, and also we have to do same thing, id x is greater than equal to 1. and we have to do what is our pre is going, let's just take it as a 0 because uh it's not matter. Mm, yeah, so string and one is going to be a two string L, and string and two is going to be a two string R. Firstly it's a 0, then we have to pass and one, or we can say and two, sorry, and two, and then we have to what index is going to be a 0 and k is going to be a k, and the initially type is going to be a, we can say that it is going to be a false, we can place anything. And then we have to do something like k and 0 comma and 1 f and 1 comma 0 comma k comma false. So let's see what is the output for this. So it's giving answer of 10 for number from, so let's print this and 1 and 2. So initially type is going to be a true, because we cannot place like a larger value at first place. So let's see what it is giving answer what and 2, and for and 2 it is giving 0, for and 1 it is going giving us 11. So let's see what is l- debug this thing, what is pre, what is and uh, what is index, what is value of type. Let's see. So initially the pre is 0 and distance index is 0 and the type is 1. So after that, so let me write it here. So firstly we have pre as 0, and then end as 10, and index is 0, and the type is initially it is 1. So after that we add 0, we choose 0, then our end will remain 10, and index is 1. We move to index, next index 1, and the type is going to be 0. After that we add 0, and then we get answer. So let me make it as a string t, and simply whenever we are in t dot push back id I plus 1 t dot pop back. Similarly here also. So now at every step we are going to, whenever we guess answer, we are going to print the t thing. Plus 0. So firstly we get 0 0, then we get 0 1 0 2 0 3 0 4 0 5 0 6 0 7 0 8 0 9 0 10. At last we get 11 as the k is 1. So yeah, for 11 we are getting everything as correct. But why for and to like a 15 we are getting a wrong answer? For I equal to 1, how can type be a 1 if it is a 0? Previously it was 0. If index is greater than or equal to 1, so when it was I was 0, we add firstly add pre as 0, and then for other index we add 0 0, then index 1 become 1. So yeah, so how we can fix this thing? So we have something like initially pre was 0, and end was 15, and index was 0, and the type was 1. So after that we choose 0. As we choose 0, so type is going to be become 0. So yeah, so after that type is 0, and index is greater than 0. Yeah. So yeah. So like if I am thinking right, then for y and 1 it is giving us a for and 1 it is 2. 1 0. I think it is correct. So you can think in 0 and a 7 the difference is already a 7. So we can't choose that number. But we have to specifically mention that like that thing. If it is the first thing uh if we have something like 0 0 9, we can choose this thing. But if we have something like choose 1, then again we choose 0. Now we cannot choose 9 because the we have choose 0 in middle. If we are choosing starting 0 at start place, then we can choose as larger number as that. So I think I have to take care of that thing also. So let's see how we're going to do. So how we can do this thing. So like how is it even possible like we get answer for 0 6? I am thinking that like that. Like 0 6 is not even possible, no? Pre, comma, con, current that is IDX one. So instead of, so I am doing wrong thing, like we have to do pre comma I value. I am doing current thing. So now I think I will get the correct answer. Yeah, you can see now we are getting like 0 0 0 0 1 1 2. Oh, sorry, 0 0 0 1 and 1 0. But we also have to check this condition. If it's a 0, like and already 0, like we can simply say that initial initial zeros, like it's if it's initial zeros, uh yeah, and the if initial zeros is equal to 1, uh we can do like, so if I equal to 0 and initial zeros equal to initial 0 is true. So initially we can assume that initial true will going to be a true, and we can make it as a true. And if I equal to 0 and initial true is true, uh yeah, then initial 0 is going to be a true, else initial 0 is going to become a false. Like you can say, like if there is a first 0, we have choose something number, like we have something like this random number, and we choose 0 here. Now initial 0 is 0. Then again for next time we choose 0, and we check if the previously we have not chosen any number other than 0, then it will also again going to be a true, because after that this thing we can again choose here 9 also now. So yeah, that thing, and we need initial zeros to be a not of initial 0, like it's not initial 0, and same thing we also have to add, and not of initial zeros, I think. And we have to make this initial 0 at initially as true. So let's see now. Similarly we have to do same thing with here also. So we can do this thing outside also. We are not getting this answer. Let me print this initial 0 also. Initial zeros. Initial zeros. So I think the code has become completely mess. I am also not understanding what I am doing here. But let's see. Let's complete this. I think it will going to work. What we can do, like so first thing is like I am checking like if I is greater than current. So we have to check this only if also we need to check like if the index is greater than equal to 1 and it's not initial zeros also. Again I am getting 3, but I should get here like I think I should get 10 answer here in case of 10. I am checking for 10. uh yeah, and 1 is 10. So I am checking if the I is greater than current and index must be greater than or equal to 1 and it's a not initial zeros, then you can break this thing. So what is the value of, so yeah, I choose 2 as a last and index is going to be a 1, not, I think first I have to check for 0 0 cases. Yeah, so the first value is going to be a 0, then I add a last value as a 0 0, so it become 1. After that it becomes 0 1 0. So initial 0 initial value, I think it must be let me write t here also. T is 0. If t is 0, I only check for these three cases like and is 0 1 1. How is it even possible? Like I am checking from I equal to 0 I till 9. If the type is true, COT comma type. So t is empty and the type is 1. If when t is 0, the type is 0. That is type is false. Yeah. If index is greater than 1, true, and not initial 0. So also let's say initial zeros here also. Initial zeros. It's 1. But in case of this, that how tight is yeah, tight is 0, that's also correct. So when tight is 0, So in case of 2, what happen? Absolute of pre comma I is greater than k. This condition is true. But initial 0 not of initial is true. Not of initial is false, no? Let me write something like this. Initial zeros must be equal to 0. Oh yeah, shit. So I should write something like this. If I equal to 0 and initial zeros true, then I have to write initial 0 as true, else 0. Because like if we do something like this, so value get updated to 0, and after that it uses that same value. Let me now do something like this here also, and then we can simply remove this code. And for also, now let's see. Now it's working. For and 2, what is the answer? For and 2 answer is 13. 0, yeah, 0 10. 10 mean 10 11. After that 1 1 and 1 2. I think it is working fine. So yeah, so let's see 201 and 204, or we can simply take some bigger number because we already had code for this. We can simply take something like 1 12 2 1 4 2 3 4, and we can take the k as 5. So yeah, so let's see what is answer for this. The answer is 7892. What was answer? 7892. 7892. Answer is wrong. 0 and 1 comma 0 comma k comma true. Again we are getting wrong answer. I am getting the answer as 14234. Let me also print the value of k. What is the value of k? Oh, wait, this is like why I'm getting working as 9. T was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. 5 digit T is this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, then 20, 21, 22, 20, 24, 27, 30, 31, 32, 30, 34, 35, 36, 37. So let's do this. What is the answer for this? 5144. So instead of doing this, let's do for 100. Let's see what is the answer. For 100 answer is 84. For 100 answer is 84. For and 2 I get 84. Yeah, this is thing correct. But for and 1 I get as 15. How is it even possible? For from 0 to 10 I get a value as 50. So yeah, so I miss this case. Like if first value become like a greater, like you can say we made something like for you can see like we have made t is 20, like we add 2, then we add 0. So we can simply make initial value to a false, and then check here. So in this case, index is OY. Now I think it should work. So let's see what is answer for 100. Answer for 100 is 64. So let's simply rewrite this code again. So instead of firstly writing the code, let me simply define all the condition. So first case is like we can add 0, 0, and then like we can add something like here a larger number also. If the first value is 0, it means that type is always going to be a yeah, true, I think. Let me again check this thing. So I am checking like if I is greater than current and not of initial zeros. Because when the first is zero and the tight is also going to become zero. Like tight is zero in this case, value previous value is 0 6 and the tight is 0. Yeah, this is correct. Like if tight is 0, this will come in this condition. And if the index is greater than 1 and initial 0 0, what is pre value? Like pre is going to be a similar to t last value only. Yeah, pre is 6. So we can add 6 7 now. Oh shit. So I am doing, we I have to do continue. Let's now check. 8226. I think now it should work. Not correct again. I think it was something else. It was like 78982. Yeah, I am getting something else. Like, can it be equal to or we have to less than always? Strictly less or is at most k? Then I think it's correct. So let's try for 100. Only 10 comma 100. The answer is 83. 10 comma 100 comma 5. and the answer should be 75. So for 100 it is giving a wrong answer. For 100 the answer should be 85 and it is giving us 109. So I am simply checking. I remember that if I equal to 0 I am simply making it as 0, but I also have to check initial zeros also should be a 0 in that case. If I equal to 0 and initial 0 equal to 0, or I equal to 0 and I dx equal to 0, then we can simply make this as again getting wrong answer. Yeah, 1005 is answer is 74. 1005, 1005. 12. So yeah, so I think if I can do something like this it should work. So I have to do L minus 1. So yeah, I think it is working. So only one thing left is the memoization thing. So what are the changing variables? So firstly, like uh let's define it globally in dp of firstly the first change is changing is the pre, and then we have something like index, and then we have tight, like of type of 2, like initial 0 can also be a 2, like a 0 or 1 value, and index can be up to, we can say, 20, or pre value can be up to 9. So yeah, I think this is the dp state, and we can simply check if dp of pre comma index comma type comma initial zeros is not equal to -1, we can simply return this same thing. and we can simply maintain this, and we use something like uh, ll answer equal to answer minus equal to, and then we do mem set dp comma minus 1 comma size of dp, mem set comma dp comma minus 1 comma size of dp, and last simply return answer. So let's see if it is working or not. Working or not. So yeah, it is working fine. So let's run it for some big test case like this. So yeah, it is working, I think. So yeah, you can see that it is working. So why it is not showing here? Let's again submit this thing. Okay, the contest is over. I think that's why. So yeah, so you can see like I was able to solve the first three problem easily, but the fourth one take lot of time. Like it consume I think around 1.5 hour. So yeah, so I hope you like this video. So like I will try to make a video on this concept, like how we can approach a problem like this. Also, as I am solving a problems after like last time I solved a DSA problem was in Jan, I think, when I gave the Amazon interview. So yeah, so after that I never, I hardly solve like a one to give contest, like one to contest after January. So yeah, so now I will regularly solve the problem. So I think it was a pretty easy problem because I already seen that like similar concept. So I think it will hardly take like around 20 minutes if you are regularly solving the problem. So I think I you enjoy this video. So I am going to like upload this raw video. Like I am not going to edit or do anything. So simply like I will stop recording and simply I will upload that video on the YouTube. So yeah, so if you like this video, or like if I whenever like now I have 11 subscriber, when I will get like 100 subscriber, I will try to come live and solve the problems. And like we can also do like a meet, or we can make Discord. So like if anyone interested, they can also join that live, and we can solve the problems. And also like I am thinking of making a videos on high level design and low level design, like as I am also studying that thing for interview. So like yeah, that's from my side. So hope you enjoyed that video. Thanks for watching the video.